Okay, so this is the part of the lesson that we didn't quite get to today. And so for this one, we're just going to do some synthetic division over here, and I'll explain this in just a minute as to why we're doing synthetic division here. So when the factor is x plus 1, of course, the solution would be negative 1. That's the value I put in the box. Take my coefficients, 2, negative 3, and 1, put them over here. And I'm just going to perform your basic synthetic division. Bring the 2 down. Negative 1 times 2 is negative 2. Add, you get negative 5. Negative 1 times negative 5 is 5. And we get a remainder of 6. That's my remainder. And then if I wanted to put a constant here, this is the x term and so forth. But my remainder is 6. Let's do a similar problem over here. Notice that much of this problem is very similar to what you just did. We have, this is the same. And really, this value here, our solution, our potential solution here, is the value that we're plugging into the function. That's kind of interesting. Let's see what happens. So I'm going to plug this in. And this is actually a little harder to do mathematically. There's more errors that happen when students start squaring negative numbers and things. And so this is a little easier process over here. I'm just going to plug this into the function. 3 times negative 1 plus 1. So I'll try not to make an error here. The negative 1 squared is 1, 2 times 1 is that, minus, this is a boom boom. So we go plus 3, and then plus 1. And 2 plus 3 plus 1 is 6. Well, you may notice something interesting now. The remainder over here is 6, and when I plug negative 1 into the function, I got 6. Well, guess what the remainder theorem says? That if you synthetically divide out that number there, that your remainder will be the same as if you had plugged it into the function. Now we have a way to double check ourselves, but I want you to use this method rather than this method. This is your double check over here, which would be fine to do, to double check that you're right. But this is the method I want, and if the question is, two things you might see. Use the remainder theorem, or you might see these words. Use synthetic substitution, which is code word for use the remainder theorem. That is your answer. Don't circle that as your answer if this is the question. Use the remainder theorem to find out what f of negative 1 is. You're going to use synthetic division and circle your remainder as your solution. If you want to try one more, we can do that. So if it said use synthetic substitution or use the remainder theorem, all I would do here is put negative 3 in the box, take my coefficients 1, 3, negative 2, negative 6. This is a very quick problem. Get 1, negative 3, 0, 0, negative 2, 6, 0. My remainder is 0, so guess what? If I were to have plugged in, that's my answer. If I plugged negative 3 into this function, guess what I would get? 0 as my answer. So that's the way synthetic substitution, that's where the remainder theorem works. I've essentially plugged that in by doing synthetic division and only concentrating on the solution. So it's a way of using synthetic substitution to accomplish a different kind of task.